So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AQA AS Maths paper of May 2020, paper 2, section A, which is the pure side. Now as always, I'll include a question breakdown in the description below so you can see which topic refers to which question. So let's get straight into this May 2020, paper 2, section A. So looking at question 1, it says identify the expression that is equivalent to e to the power of minus 2 over 5. So all we need to do is just convert the power to what it actually represents. So here we've got a negative, so that means it's going to be a reciprocal, and we've got e to the power of 2 over 5. Now remember that the power of the fraction is usually represented in the denominator, in the numerator rather, so that'll be e squared, and then it's to the fifth root, so we're looking for 1 over the fifth root of e squared, which is our first option. Then moving on to question 2, it says it is given that y equals 1 over x and x is less than minus 1. Determine which statement below fully describes the possible values of y. So if we start by actually just drawing the graph of y, 1 over x, let's just use this, and it looks something like this. I'll just label what that graph is. Now in this particular question we're looking for x values that are less than 1, so we'll just imagine minus 1 is here. So we're looking for, now that value there, y is going to be equal to minus 1 over 1, which is just minus 1. So this is here is minus 1. Now the range of values of y when x is less than minus 1 is this range here. So we're looking for what this range here is going to be, and that's going to be from 0 to minus 1. So the correct answer we need to tick is going to be our third option. Then moving on to question 3, it says that it is given that y equals 3x to the power of 4 plus 2 over x minus x over 4 plus 1. Find an expression for the second derivative. So first things first, it's always good practice to convert the original equation so that we write it in index form. So that's going to be 3x to the power of 4 plus 2x to the minus 1 minus, and it's going to be a quarter x plus 1. Then from this, what I can then do is then work out what dy over dx is going to be. And again, the rules of differentiation is move the power to the front, lower the power by 1. So that's going to be 12x cubed minus 2x to the minus 2 minus a quarter. And then from this we can then work out what the second derivative is going to be by just repeating the process of the rules of differentiation. So that's going to be 36x squared plus 4x to the minus 3, or you could write it as 36x squared plus 4 over x cubed. Then moving on to question 4, it says find all the solutions of 9 sine squared x minus 6 sine x plus cos squared x equals 0, where x is between and inclusive of the range of 0 to 180. Give your solutions to the nearest degree and fully justify your answer. So looking at this, what we want to try and do is just have an equation where it just involves sine. So what we need to do is we need to use the trig identity to work out what this is going to be. So we know that cos squared x is equal to 1 minus sine squared x. So if I substitute that in, I'm going to end up with something that looks like this. And then I can just simplify. So here I end up with 8 sine squared x minus 6 sine x plus 1 equals 0. Now from this, you should be able to spot that this looks like a quadratic. So I can either write it as, imagine like if I said y equals sine x, then I'm going to end up with 8y squared minus 6y plus 1. If you find that easier to work with, or you can just deal with how it's written in trig form. So, but it does factorize, in which we get 4 sine x minus 1 and 2 sine x minus 1 equals 0. Then from this I can then go on to solve it. So if each bracket equals 0, so 4 sine x minus 1 equals 0. So sine x is going to equal a quarter. And if I just type this into the calculator to solve. Now remember that we do need to make sure that we're rounding to the nearest degree and make sure that all our angles are in the range of 0 to 180 inclusive of those angles. So inverse sine of 0.25 is going to give me an answer to the nearest degree of 14 degrees and 165 degrees. Then all that's left for me to then do is repeat the process, but for 2 sine x minus 1 equals 0. So 2 sine x minus 1 equals 0. Doing a bit of rearranging gives me sine x equals a half. So sine x to 0.5 equals x. Just write equals x here. And that will give me another set of values, which if I type into my calculator now, I get an answer of 30. And I'm going to get an answer of 150. And there we go. Then moving on to question 5, it says Joseph is expanding 2 minus 3x to the power of 7 in ascending powers of x. He states that the coefficient of the fourth term is 15,120. Joseph's teacher comments that his answer is almost correct. Using a suitable calculation, explain the teacher's comment. Now there's numerous ways in which you can go about finding a particular coefficient of x in a binomial expansion. So any really method you can do. If you want to expand it fully, that's entirely up to you. It depends on just how quick you are, but do be mindful of how much time you are taking for this particular question. Now the fourth term is going to be the coefficient of x cubed if it's in ascending powers of x. So then using the quick way of doing this, so we've got our general power of 7, looking for x cubed multiplied, and then we've got 2 to the power of 4 times minus 3x to the power of 3. Now if you're not sure where that's come from, well, if I'm looking for the coefficient of x to the power of r, then in, let's say, a plus bx to the power of n, then it's going to be n r, using the NCR function on your calculator. It's going to be the first term to the power of n minus r multiplied by the second term, which will be your coefficient, which will involve your x to the power of r. So if I substitute those values into this, this is what I get. And if I type that all into my calculator, I get an answer of minus 15,120 x cubed. So this is the coefficient. So he was pretty close. The only thing that he forgot was the sign. So Joseph just forgot the negative sign. So something along those lines would be absolutely fine. Then moving on to question 6, it says that a circle has the equation of x squared plus y squared plus 10x minus 4y minus 71 equals 0. And the question is asking us to find the centre of the circle. So for this, if we look at the pairs, so here we've got, if I just write this out, so x plus 10x plus y squared minus 4y equals 71. Then factorising the pairs here, we get x plus 5 squared minus 25 plus y minus 2 squared minus 4 equals 71. Now the question is only asking me about the centre, so I don't need to work out the radius or anything like that. So here we know that the centre, therefore, is going to be minus 5 and 2. Now typically, if you could see what the centre is going to be straight away, then where you'd get the 2 marks is one, having the correct x ordinate, and the second mark would come from the correct y ordinate. So if you can spot the centre, which many of you probably can, once you've developed an understanding of equations of a circle, then it will be fine just to go straight to the answer for the 2 marks. So then moving on to 6b, it says, hence find the equation of the tangent to the circle at point 110, giving your answer in the form of ax plus by plus c equals 0, where a, b and c are integers. So the first thing I need to do for this is to find the gradient of the centre to the point. Now the centre is minus 5, 2. And the point is 1, 10. So then using y2 minus y1 over x2 minus x1, I get 10, 1, and then 2 minus 5 minus minus, and so I've got 8 over 6, which is 4 over 3. Then to work out the gradient of the tangent, because that's the gradient of the normal, is going to be minus 1 over 4 over 3, which is 3 over 4, which is a negative. Then from this I can then use the coordinate of 1, 10 and substitute that all into the equation of a straight line, which is y minus y1 equals mx minus x1, where this is my value of m, in which then I get y minus 10 equals minus 3 over 4 x minus 1. Then if I do a bit of expanding of the bracket, or take the fraction over, well, let's take the denominator over, I end up with 4y minus 40 equals minus 3x plus 3. And then joining everything all onto one side, I get 4y plus 3x minus 43 equals 0. Now moving on to question 7, it says the population of a country was 3.6 million in 1989. It grew exponentially to reach 6 million in 2019. Estimate the population of the country in 2049 if the exponential growth continues unchanged. So for this, there are particularly two ways. Now, I would say the most logical way is probably the longest way, but it is only 2 marks. So if you know the quick way and you do that, that's going to be fine. But the method I'll show you will probably make more sense, but the problem is it will take a little bit longer. So first of all, what we need to do is establish a formula. So we know that it's an exponential formula. So we know that here we've got a population which we'll just call n is equal to a, which is our initial value, multiplied by the increasing rate over time. Now let me just make sure that that represents a multiplier, not xx. Now from this we can see that our initial value a is 3.6 million. So if I substitute that into the formula, and we know that when t equals 30, that n equals 6. So then substituting all that bit of information in, we get 6 equals 3.6 times x to the power of 30. Now what we need to then do is solve this for x. So then what we've then got is 6 divided by 3.6 equals x to the power of 30. So then x equals the 30 root, which may seem crazy because you've probably never gone that far before, and gives us an x value of 1.017. So that's my x value. So then the formula then is n equals, and it's going to be 3.6 times 1.017 to 3 decimal places to the power of t. Now we're going to add on, so the question is asking us to find n when t equals 60. So then if I then substitute that all in, I get 3.6 multiplied by 1.017 to the power of 60, and that gives me an answer of around about 9.9 million, which is approximately 10 million. And there is my answer. Now another way of going around this particular question is, because we're looking at 30 years and we want another 30 years, then we just need to calculate the rate. So the rate is going to be 6 divided by 3.6, and that equals 5 over 3. So then if I then do 6 times 5 over 3, I still get the answer of 10 million. But that only is convenient because we're looking at 1989, and then 30 years onward to 2019, and then another 30 years. So because of there's the same amount of increase in terms of the years, we couldn't use this method if it was a 30 years and then a 20 years, or 30 years and then a 19 years, let's say. This method particularly wouldn't work, but the method that I did initially would work for all types of these types of questions. Then moving on to question 8.8, says using y equals 2 to the power of 2x as a substitution, show that 16 to the power of x minus 2 to the power of 2x plus 3 minus 9 equals 0 can be written as y squared minus 8y minus 9 equals 0. So first things first, what we need to do is rewrite this expression here. So 16x squared, and we want to write that so that it looks something that incorporates the y value. So 16 to the power of x, well, I can write 16 as a power of 2 because that's 2 to the power of 4. And so I can write that's x, so that's going to give me 2 to the power of 4x. Then looking at 2 to the power of 2x plus 3, well, I can write that as 2 to the power of 2x multiplied by 2 to the power of 3. So then from this, what we then have is that 2 to the power of 3 is 8 multiplied by 2 to the power of 2x, or 2 to the power of 2x rather. So just joining those two things, I'm going to leave that as 8, and I'm going to write 2 to the power of 2x. Now, the reason why I've written it with the brackets rather than writing it like this will be explained in due course. So then what I can then do is just highlight that in pink. So then going back to the original equation, I'm going to swap this with this and swap this with this. So what I then get is, rather than writing 16 to the power of x, I'm going to write 2 to the power of 4x, and instead of writing 2 to the power of 2x plus 3, instead I'm going to write 8 to the power of 8 multiplied by 2 to the 2x minus 9 equals 0. Now if I then let y equal 2 to the power of x, then another way of writing this is going to be 2 to the power of 2x times 2. So if I write it like that, then this is therefore incorporating y. If the bracket, this bracket is going to equal y, so that's going to be y squared. This is going to be 8y minus 9 equals 0, which is what they wanted me to show. Then moving on to 8b, it says show that the equations, which is written, I'm not going to read out, has x equals log to the base 2, 3 as its only solution, and fully justify your answer. So if I go back to the original quadratic involving y, we get this. Now solving this, either using factorizing or by using quadratic form or your calculator, we get y equals 9 or minus 1. So then substituting our y back in, so we know that y equals 2 to the power of 2x, so that means that 2 to the power of 2x equals 9, or 2 to the power of 2x equals minus 1. Now for this there are no solutions, so we're only working with this. So taking this out and writing this in the form of logs, then we get log to the base 2 of 9 equals 2x. Oh, what's happened there? Equals 2x. So then from this we can then go about solving this. So I can enter this on the calculator. So this then becomes, well, it actually wants me in exact form, so I can write that as log to base 2 of 3 squared. So that becomes 2 log 2 3 equals 2x. If I divide both sides by 2, I lose the 2's, so therefore x equals log 2 of 3. Then moving on to question 9ai, it says find the integral of 4x minus x cubed dx. So for this, what we need to do first is just use the basic rules of integration. So we increase the power by 1, divide by the new power. So this is going to be 4x squared divided by 2 minus x to the power of 4 divided by 4, and again don't forget that plus c. So then simplifying that, we end up with 2x squared minus, and you can either write it as x over 4 plus c, or you could write it as 2x squared minus a quarter x to the power of 4 plus c, but do not forget that plus c in this question. Then for 9aii, it says evaluate the integral with the limits of 2 minus 2. Now typically what you could do is you could just stick this in your calculator, and with it only being worth 1 mark, that'll be absolutely fine. So I would again use your calculator, and you should end up with the answer of 0. The next question then says, using the sketch, explain why the integral in part aii does not give the area enclosed between the curve of y equals 4x minus x cubed and the x-axis. Well, the reason for that is because if I actually draw a set of axes, which I will draw generally roughly accurately, let's click that in black, then what the actual graph looks like is it looks something like this, which is probably poorly drawn, but our limits here are minus 2 and 2. Now here we just need to write some statements saying that the reason why it's 0 is because the area between the limits of minus 2 and 0 is negative, but it's also the same area. So this area here is the same as this area here. So they actually cancel each other out. So in terms of what you write, well, I would personally write something along the lines of the area between minus 2 and 0 and 0 and 2 is the same. However, the area between minus 2 and 0 is below the x-axis, so will give a negative answer when integrating. And so something along those lines would be good enough for the 2 marks. It then says for 9c, find the area enclosed between the curve of y equals 4x minus x cubed and the x-axis. So what we need to do for here is, if we work out the area of 2 to 0, then the actual area will be 2 lots of it. So it's going to be 4x minus x cubed dx. And if I type that all into my calculator, I'm going to get an answer of 4, but I need to times that by 2. So then the total area is going to be 8 square units. And then moving on to question 10, it says that a curve has the gradient function of dy dx equals 3x squared minus 12x plus c, and the curve has a turning point at minus 1, 1. Find the coordinates of the other turning point of the curve. Fully justify your answer. Now, the reason why it says fully justify your answer is because if you've got access to a graphic calculator, what they don't want you to do is to plot it and then use your calculator with very little working out, particularly when the question is worth 6 marks. So first things first, let's just state some facts. So at the turning point, dy over dx is going to equal 0 because it is going to be a stationary point. So that means that 3x squared minus 12x plus c equals 0. Then if I substitute minus 1 in there, so when x equals minus 1, we get 3 plus, oh, it's going to be, let me write it properly, so we get 3 minus 12 lots of minus 1 plus c equals 0, and so we get a c value of minus 15. So then from this, what we then get is that our dy dx is therefore going to equal 3x squared minus 12x minus 15. Then using this, and we know that we're trying to find the other turning point, so we then make this equal to 0. So we've got 3x squared minus 12x minus 15 equals 0. And then we can then go on to solve this. So I would say to use the calculator, save a bit of time. So use the calc or the formula, or by factorizing, in which we get two values of x equals 5 and x equals -1. So here we know that we already know this turning point, so we know this already. So the one we need to investigate is when x equals 5. So what we then got is we then need to find what the original equation is going to be. So now that I know that the x ordinate is at x equals 5, I then need to find the y ordinate, and in order to do that I need to find the original equation. So for this, we know that dy over dx equals 3x squared minus 12x minus 15. So then doing some integrating, we get y equals, and it's going to be x cubed minus 12x squared over 2 minus 15x plus c. Now just simplifying that, just to make it easier on the eye, we get this. Then what we then need to do is we know that a coordinate exists. So we know that when x is -1, I've got my coordinates the wrong way around there, so let me just correct that, of 1, we can then find this. So use to find c. So then creating a bit more space, so substituting the values of this, we get 1 equals -1 cubed minus 6 minus 1 squared minus 15 minus 1 plus c, in which I get an answer of c equals -7. So that means that the equation of the original curve is going to be y equals x cubed minus 6x squared minus 15x minus 7. Now when x equals -5, or no, it's actually +5, y is going to equal -107. So the turning point is at 5 minus 107. Then moving on to question 10b, it says find the set of values for x for which y is increasing. So if I just do a little mini sketch of what the curve actually looked like, and I know that it's going to look something like this, and I know what the two turning points are, so I know that this turning point here, excuse the poor diagram, is at -1, 1. And I know that this turning point here is at 5 minus 107. So I'm looking for where the gradient is positive, and it's positive in this region here and this region here. So it's going to be increasing when x is less than -1 or when x is greater than 5. Then moving on to our last question on this section A, it says that a fire crew is tackling a grass fire on horizontal ground. The crew directs a single jet of water which flows continuously from point A. The path of the jet can be modelled by the equation of y equals -0.0125x squared plus 0.5x minus 2.55, where x meters is the horizontal distance of the jet from the fire truck at O, and y meters is the height of the jet above the ground. The coordinates of A are A0. Find the values of A. So first things first, what we need to do is we need to substitute the y ordinate to then find out what A is. So if we substitute this coordinate into this equation, then what we end up with is -0.0125, and then we're going to have A squared plus 0.5A minus 2.55 equals 0. Now this then turns into quadratic, so use the calculator to solve the quadratic, or use the quadratic formula. If you don't have that feature on your calculator with you. So, but it does actually factorize if we get our values up. But basically, you can either have it recognize that the equation is x squared minus 40x plus 204 equals 0. And that factorizes as x minus 6, x minus 24 equals 0. But in other words, we get two x values of x equals 6 or x equals 34. Now, this is where the jet starts off. So again, we're not looking at x, we're looking at a. So let me just start by correcting that and stick an a there. Now, I don't think they'll be as harsh to knock your marks of this, but as long as you recognise then that x is a. So this is where the jet is initially. And this is where the jet ends. So our a value is going to be this one here. Next question then says find the horizontal distance from A to the point where the jet hits the ground. So for this it's just going to be 34 minus the initial length, which is 6, and that gives us an answer of 28 meters. Then for 11b it says calculate the maximum vertical height reached by the jet. So for this what we need to do is just recognize that it's going to be a turning point. So the maximum height equals the turning point of the parabola. So for this we know that it's going to be dy over dx equals 0. So then if I then work out dy over dx, which is going to be minus 0.025x plus 0.5, and that equals 0. So then solving this, I get x equals 20. It's this that I'm solving. So then I know from this then the maximum height is going to be when x equals 20. So it's going to equal minus 0.0125 times 20 squared plus 0.5 times 20 minus 2.55, and that gives me an answer of 2.45 meters. Then moving on to our very last part, it says the vertical wall is located 11 meters horizontally from A in the direction of the jet. The height of the wall is 2.3 meters. Using the model, determine whether the jet passes over the wall, stating any necessary model assumptions. So for this, we know that x equals 6 rather. So we know that that's the initial distance. We know that plus 11 is going to equal 17 meters, because again we're looking at the vertical wall is located 11 meters away. So this is the distance of the wall. So then from this, when x equals 17, I then substitute that into the formula and we get a y value of 2.3375. So again, does that clear it? Well, assuming the jet of water has no size in terms of thickness, in terms of this jet of stream, or the width, as 2.3375 is less than 2, is greater than 2.3, then 2.3, because that's the height of the wall, and this is the curve. So let me just write the curve, and this is the wall. Then it clears the wall. So something along those lines would be absolutely fine.